Hello, this is the Water Vapor Lab health video, and I thought I would just basically go over a few tips here for you. When you start this lab, make sure and you click on the audio file here. This might give you some tips on how to answer the questions, but I'm going to go over each one of these questions very quickly to show you how I want you to do them. Question 1. Please define the 3 states of water in terms used to define the phase changes of water. All of those answers can be addressed by watching this short video, and all of the terms that you're going to be needing to answer will come up in this video. It's a 4-minute video, and it's just basically a terminology lab to assist you to understand water and how it exists in its 3 states, and when water goes from its 3 states, what are the terms we use to describe those phase changes of water. Question 2 is another terminology question, a very easy question. Basically, all indicators of ways in which we describe how much water vapor or humidity is in the air, and the way in which we describe the units and the way in which we measure that humidity: vapor pressure, absolute humidity, relative humidity, and dew point. These are all ways of measuring water vapor, which is basically water in the air in the gas form, and these are all ways in which we measure it. To answer that question, there is no video associated with it, but under your home button, I'm going here to kind of show you how I would do it. To make sure you're following along, you could watch the lecture, and all of the answers to those questions would be under Module 1, under the readings and assignments. And as this page loads in, you would scroll down, and I have a lecture video here for Chapter 5 and my lecture notes right here. If you start about minute 13, you got about 45 minutes of our professor, Dr. Ferguson, who just gives an excellent lecture on the different states of water and humidity indicators. And when you answer your questions for vapor pressure, absolute humidity, relative humidity, and dew point, you have to give me the technical definition and the units in which they're measured in. And the units of these different measures could be in grams per kilogram, it could be a percentage, it could be a temperature, or it could be millibars of vapor pressure. So depending upon which term you're dealing with, you'll realize that we can measure humidity in the air in different ways, and the answer to those questions can be all found either in my lecture notes here for question 2 or the instructor lecture here from Dr. Ferguson at the University of California at Irvine. Now I'm going to get back into the lab again on water vapor. Give me a second for it to open up. I'm trying to move very quickly here, just as trying to put a quick video together here, so you will be able to kind of get when you go through the video or go through the lab, you won't have any questions. So we're back on the water vapor lab, and we're now on question 3. Question 3 entails you watching this instructor right here, and the whole point of him using this, and as the video loads in, I'll actually even start it. You could see, I believe he's from Arkansas, so I'll have a nice southern accent. He's going to show you beakers, and basically, I'm going to stop it because I don't want his voice to overlap mine. But these beakers represent air at different temperatures, and he's going to start filling them up with liquid water. And he's trying to show you that when air is warmer, it can hold more water vapor. And the liquid water in there is to really represent water vapor. And he uses liquid water because you can see it and you can't see water vapor or humidity. So you could kind of basically look at this large flask right here as the equator, and the smaller one maybe is the North Pole. And what you're to see as air warms up from the equator to the North Pole, as it warms up, it can hold more water vapor. And effectively, I ask you 2 basic questions. What are the 2 different ways in which you could saturate air to make it saturated to 100% relative humidity? And that would mean when the water goes clear to the top of one of these cups, that means the air is absolutely full and 100% saturated. So watch for his examples of what are 2 things he can do to make the water get to the very top. And he's basically showing you different ways in which you can manipulate relative humidity. I would say the hardest question set is question set 4. This guy basically teaches you how to read a vapor pressure, saturation vapor pressure graph, and teaches you how to understand how to calculate ultimately relative humidity. Pay very close attention to when he gives examples of how to calculate and read the chart to know how much water vapor is there versus how much it can hold at a given temperature, and that will give you an insight of how to calculate relative humidity. The whole chart, when you click on it here, and I'll have it load in, the chart basically is a way of looking at, when you look at it, the x-axis is basically the air temperature and the y-axis is the saturation vapor pressure. And what you're supposed to learn from this graph is the air becomes warmer, the air can hold more water vapor in the form of vapor pressure. And he gives you a number of examples to show you, based on how to use this graph, you could actually calculate how close the air is to being saturated. And again, so when the air is very cool, it could hold very little water vapor, and as the air warms up, it can increasingly become more saturated. And I would argue probably this is the one of the more complicated parts of the lab, is learning how to read this chart. And the reason why I had you looking at El Paso, Texas and Seattle, Washington, is these are 2 environments that one is typically very dry, almost in a semi-arid desert, and one is in a very saturated or very moist environment with a lot of fog. And so that's why I picked 2 cities that are in very different environments for understanding humidity. El Paso tends to be dry in Seattle, so you should have one location should be very dry and not near 100%, and one location will be very close to being saturated. So that is that question set. And question set 5 is basically teaches you how we calculate relative humidity and dew point using a sling psychrometer. So if you watch this video shows you one of the most basic examples of how to use a sling psychrometer. And ultimately, I'm going to stop the video. He'll show you basically how you'll end up using an instrument, and he'll show you how to use a graph, and you'll actually be able to see how you can calculate 2 key indicators of how close the air is to being saturated using an instrument called a sling psychrometer. Question set 6 is very simple, where basically it's the water cycle. And you will watch a video here, and then within this video you will very quickly learn how to understand how water moves between its 3 different phases as either a solid, liquid, or gas, and how basically through weather and climate that the phases of water are constantly moving and being exchanged from the oceans to the air to the land, and then eventually the water will return back to the oceans. So I ask you 4 basic questions here about the water cycle, and all 4 of these questions are directly answered on the video itself. So I will stop there, and I hope that helps you understand how to use the videos to answer the questions on the Water Vapor Lab.